Hello everyone. If we study manufacturing of any chemicals, then in every chemical manufacturing process description, certain operating conditions are mentioned. If these are catalytic reaction, then the catalyst used is mentioned. Now, in that description, there is only one temperature and pressure or the relevant conditions maintained. Now, if that is the case, then what is the meaning of this title? Factors which affects the rate of reaction. So the meaning of this is, for every reaction, there are some optimum conditions at which the reactions can be carried out. And those optimum conditions are mentioned in the process description. Now in this session, we'll try to understand which factors affects the rate of reaction. So to begin with, every chemical reaction involves interaction between reactant molecules at a fixed set of operating conditions. And depending upon the type of the reaction which we are carrying out, there may be one or more than one operating variables which influence the rate and extent of reaction. Now, as a chemical engineer, or whenever we are planning to carry out that reaction on an industrial scale, then our objective is effective control of the reaction. Now effective control means control of the process variables, maybe temperature, pressure, the progress of reaction, etc. And we always aim at getting the best possible conversion or yield. As a chemical engineer, our main interest should be in the yield rather than conversion. And so to obtain the best possible yield for effective control over the progress of reaction, it is important to understand which variables affects the rate of reaction. Now there are many variables which affects the rate of reaction. In some references, you may find more than these also, but I have specifically listed the important one. So the variables which affects the rate of reactions are temperature, pressure, concentration, use of catalyst, surface area, nature of reactant, and physical state of reactants. Now, which variable amongst this is important depend upon the type of the reaction which is under consideration. So for every reaction, there may be a specific set of operating variables which are important in order to drive the reactions as per our plan or as per our expectations. So let us try to understand the meaning of or the importance of each and every variable and how it affects the rate of reaction. Now first is temperature. Now this temperature provides the energy equivalent to activation energy or energy required to make or break bonds. We have studied that certain minimum amount of the energy is necessary in order to initiate the reaction, and unless and until that minimum amount of energy is supplied, the reaction cannot start, and that energy is known as activation energy. So whenever we see that certain reactions are carried out at 100 degrees Celsius or 120 degrees Celsius or 300 degrees Celsius, but they are not. So what does that temperature means? The temperature which is mentioned for that particular reaction means At this temperature, the reactant molecules are activated enough so as to make or break bonds and thereby result in the product formation, or the reaction can proceed in a forward direction and gives the product. Now, as per the kinetic theory of gas, the molecules in the gas are in a constant state of motion. They continuously collide with each other, and therefore how fast they will collide or how frequently they will collide depends upon the energy possessed by them. And as the temperature increases the thermal energy, which indirectly increases the motion of the molecules, as a result, the number of energetic collision increases and the reaction is accelerated. It is said that for every 10 degrees Celsius rise in temperature, the rate of reaction doubles. But please remember, even though for rise in temperature, the rate of reaction doubles, but to what extent we should expect the enhancement in a rate, or to what extent we should accelerate the reaction depends upon the kind of the reaction under consideration. So for example, if we are considering explosion, then in explosion, what is explosion? Explosion is basically the uncontrolled reactions in which there is a rapid rise in temperature, and as a result the blast occurs, temperature and pressure, and as a result the blast occurs. So in that case we are interested in uncontrolled reaction. But however, in an industry, whenever we are carrying out reactions, we are always interested in controlled reactions so that we can ensure the safety during the reaction as well as we can ensure the expected performance. But however, it is known that it is proven that for every 10 degrees Celsius rise in temperature, the rate of reaction doubles. Now, the effect of temperature on the rate of reaction can be estimated by using theories of temperature dependency. Now, whenever we solve the problems related to Arrhenius theory of temperature dependency, then the statements generally given are, if the reaction is carried out at so and so degree Celsius, and the value of the rate constant is some x, and if the temperature is increased to certain other variables, what will be the enhancement in a rate of reaction, or what will be the value of rate constant? So the ratio of rate constant at two different temperatures will provide us the guideline about how much is the reaction is accelerated because of increase in temperature. Now, let us try to understand the effect of second variable, pressure, right? Now, pressure is important for some specific type of the reactions. These reactions are generally variable volume reactions. And as a thumb rule, you can consider that all gaseous or many gaseous phase reaction, or say all gaseous phase reactions, are variable volume reactions, or any reactions which consist of synthesis or decomposition. Synthesis means whenever two or more reactant reacts to form one product, that is known as synthesis. And decomposition means when one compound is decomposed into more than one product, then it is known as decomposition. So whenever there is synthesis or decomposition type of the reaction, then in such cases the pressure plays the greater role, or pressure has the effect on the rate of reaction, rate and extent both. Now, in case of gaseous phase synthesis or decomposition, which I explained just now, now it does not influence the constant volume liquid phase reaction. So whenever the reactants and products both are in a liquid phase, whenever the volume of the reaction mixture does not changes during the reaction, for such type of the reaction, the pressure does not affect the rate of reaction. Now, generally the reactions in which number of moles during the product formation decreases are carried out at high temperature and high pressure. To be more specific, high temperature and high pressure. Whenever I'm saying temperature is high, it also means that pressure is also high. Now, what does it mean? Let us try to understand by examples. So this ammonia synthesis, now I was explaining what is the meaning of synthesis. When two or more reactant reacts to form one compound, so ammonia, nitrogen and hydrogen reacts to form ammonia. So if this reaction is carried out at 200 and 300 atmosphere and 500 to 550 degrees Celsius, conversion obtained is between 10 to 30%. But if same reaction is carried out at a lower pressure, 100 atmosphere and lower temperature, the conversion obtained is relatively less. So this clearly indicates that the reactions are influenced by the value of the pressure which is applied during the or which is maintained during the reactions. So generally the variable volume reactions and that too gaseous phase reactions where the volume as per the stoichiometry, the volume of the reacting mixture changes are greatly influenced by the pressure. But in general, all liquid phase reactions occurs at a constant pressure, and pressure rather than pressure, temperature is the important factor in case of the liquid phase reaction. Now concentration. Generally for all reactions except zero order reaction, the rate of reaction increases with increase in concentration. Now what is the meaning of this? Say for example, as in a fixed reactor volume, if the concentration is increased, it means that the number of molecules will increase, and if the number of molecules increases, the collision will increase, and an increased collision will result in the increased rate of reaction, because for the reaction to take place, the first and foremost conditions is the reactant molecules must collide. So the condition for the collision or the probability of the collision or the number of collisions will be more if the concentration is increased. And as a result, as the concentration increases, the rate of reaction also increases. Now, increase in concentration at optimum temperature increases the probability of energetic collisions, and thereby rate of reaction is accelerated. Now, the fourth parameters which affect the or four variable or factor which affect the rate of reaction is use of catalyst. Now, you know that every reaction or requires certain minimum amount of the energy in order to initiate the reaction. Now, higher is the energy required, higher difficult will be the reactions, and slower will be the reaction. And therefore, we are aware that the catalyst provides the path of minimum activation energy, and thereby the rate of reaction is accelerated. Now, there are two types of the catalyst. The one which accelerates the rate of desirable reaction. There are some catalysts known as negative catalyst or inhibitors, which are used to decelerate the rate of undesirable reaction. You are aware that whenever we carry out any chemical reaction, there may be one main reaction, and it is possible that there may be some side reactions which might be occurring and which results in a byproduct formation. Now, if side reaction occurs, then our yield of the reaction will decrease, and therefore, to prevent that, sometimes we would like to suppress the side reaction. So these inhibitors are the negative catalyst which decelerates the rate of undesirable reaction. And every catalyze specific type of reaction. Whenever we'll be studying the catalytic reaction, that time uh, we will try to understand how the catalyst catalyze the specific type of the reaction. Now, catalyst also facilitates the reaction because this catalyst provides the active sites where the reactants are adsorbed, and the adsorption of the reactants on an active site of the catalyst facilitates their interaction, and as a result the reaction is favored. There are different types of the catalyst: homogeneous catalyst, heterogeneous catalyst, enzymatic catalyst. Now, heterogeneous catalyst generally facilitates the gaseous phase reactions. Homogeneous catalyst were once used, even now also they are used, but now their use is discouraged because of the workup. That means the task to be completed after at the end of reaction. So some extra workups is required in case of the homogeneous reaction, and the separation of the catalyst is difficult, and therefore nowadays heterogeneous catalyst, which can be simply filtered out or can be removed out of the reaction easily, are generally used. But just to sum up our discussion, catalyst provides the path of minimum activation energy. Catalyst accelerates the desirable reaction. Catalyst suppresses or inhibits the undesirable reaction. And therefore, by catalyzing the specific type of the reaction, by providing the minimum energy, path of minimum energy, the rate of reaction is accelerated. Now, the next parameter is surface area. Now, generally, surface area has a greater influence on a rate of heterogeneous reaction using solid reactants. So, whenever the reactants, one of the reactant is in a solid, say for example, if the reactant is solid and another reactant is liquid, or second situation, if one reactant is solid and another reactant is gas, so in such case the surface area has a greater influence on the rate of heterogeneous reaction. Now, heterogeneous reactions are the one when when either one of the reactant or product or catalyst is in a different phase. Homogeneous reaction means when reactant, catalyst, and product are in a same phase. Same phase means what? All are liquid, all are say in a gas phase, like this. So now this surface area depends upon the size of the material. Now, during crushing and grinding operation or the study, we have studied that the advantage of the surface area of the material increases if its size is reduced, and therefore if the size of the material is reduced, the surface area increases, and thereby the area available for the interaction between reactants is enhanced or is increases, and thereby rate of reaction is accelerated. The simple example how the surface area and indirectly the size of the solid reactant accelerates the rate of reaction is our combustion reaction, which we observe in our day-to-day life. Suppose if we are interested in combustion of wood, then if we burn the chips, chips or pieces of the woods, they catches fire easily. But if if I try to ignite the big, large wood log, then it burns, but at very slow rate, and rather even it doesn't get ignited very easily. So this proves that the surface area greater the surface area, greater will be the rate of reactions. And sometimes you must have seen that in petroleum coal, whenever it is used in our stoves and all coal based stoves, then we normally break that particular petroleum coke and then use it. The objective of breaking is to facilitate its early ignition and thereby facilitating the proper combustion. So the reactions which involves the interaction of one of the solid reactant with either liquid or gaseous type of other reactant, such reactions are favored or are influenced because of the surface area. Now, whenever I'm saying surface area, the surface area means surface area of reactants. Even if we think about catalyst, then surface area of the catalyst can also play the important role. The catalyst, where there is the enhancement in the or where the surface area of the catalyst is higher, facilitates the greater reaction rate. Next parameter is nature of reactant. Now, this nature of reactant involved affect the reactions. Now, what does it mean? See, there are different types of the reactants. Say, for example, if I consider the reaction between silver nitrate and sodium chloride, so this both in this reaction, both the compounds are ionic compounds. So whenever both the reactants are ionic compounds, and when the reactions involve ionic interaction, such reactions occurs in at a faster rate. Whereas there are some reactions where the compounds are formed by the covalent bond, that is reactants which are involved in the reaction are formed because of the covalent bond. And now covalent bond requires more energy for making and breaking of the bonds, and therefore such reactions proceeds at a slower rate. So depending upon nature of reactant means what? If the reactants are ionic in a nature, the rate of reaction will be faster. But if the reactants are formed because of the covalent bond formation, and even the reaction itself involves the formation of the product which is formed by which is formed by the formation of covalent bond, such type of the reactions occurs in a slower manner because they require more energy. So even sometimes, say if I take the example of oxidation reaction. Now nature of reactant means what? Some oxidizing agents have very large oxidation potential. Some oxidizing agent has less oxidizing potential, and therefore the reactants or the oxidant which has high oxidation potential, if they are used as an oxidizing agent, the reaction occurs at a faster rate. Now, for example, if suppose if you consider the hydrogen peroxide, that hydrogen peroxide itself is an oxidant, but whenever the hydroxyl radical is formed, it is also an oxidizing agent, but it has got higher oxidation potential, and therefore it facilitates the faster oxidation of the pollutant or the contaminant under consideration. So in this way, the nature of reactant and the nature of the reactants involved affects the rate of reaction. The next parameter is physical state of reactants. Now, physical state of reactants also influence the rate of reaction. Say, for example, if the reactants are in a gaseous phase, both the reactants are in a same phase, that is gaseous phase, then just because of the thermal motion only, they will interact with each other, and because of that interaction the reaction will start. Because you are aware that for the reaction to take place, the reactant molecules must come in a contact, or their contacting must be facilitated, and that is much easier when the reactors are in a same phase. If, however, there are reactions, heterogeneous reactions, where one of the reactant may be in one phase and another reactant may be in another phase, or there are some reactions like ammonia synthesis and some manufacturing of other chemicals, where the catalyst used is a solid catalyst, and you are aware that unless and until the reactants sits or are absorbed on the catalyst surface, the reaction will not start. So in such case, when the physical state of the reactants or maybe even a catalyst, if they are different, then the rate of reaction may be slower, because there is a additional mass transfer resistance which is to be overcome in order to facilitate the better interaction of reactants with reactants or reactants with catalyst. So in this way, generally in a homogeneous reactions, when the reactant products catalyst are in a same phase, the reactant rates are relatively faster. But when either reactant or catalyst are in a different phase, or if two or more reactants are in a different phase, then their contacting is difficult, and the mass transfer resistance affect the rate of reaction. That is, such type of the reactions are mass transfer controlled, and they generally occurs at a slower rate. In order to accelerate them, you have to use some contacting device, or you have to adjust the reactant involved or the catalyst involved, such that the better interaction between the reactant molecules and between reactant molecules and catalyst occurs, and as a result the rate of reaction is increased. So to sum up, the rate of reaction is affected by operating variables such as pressure, temperature, concentration, nature, and physical state of reactants. Now, the effect of operating variables depends upon is different for different reactions. Now, what type of the reactions you are carrying out, that will decide the effect of operating conditions. The knowledge of effect of variables on the rate of reaction is important for optimizing the reaction performance. Now, as a chemical engineer, our objective is always to enhance the rate of reaction to facilitate the higher yield, and that is only possible by optimizing the parameters mentioned earlier, which has the greatest influence on the rate of reactions. So I hope you must have understood which variables affects the rate of reaction, how they affect, and how we can enhance the rate of reaction by manipulating the values of the variables mentioned in the discussion. Thank you. Thank you very much. So in this way, in this discussion, we have understood that the effect of the variables on the rate of reaction is the reaction specific. There are some reactions where the temperature play major role. There are some reactions where pressure play major roles. There are some reactions which occurs in a heterogeneous phase, where the phases or the mass transfer resistance also affect the rate of reactions. Sometimes even the nature of the reactant also affects the rate of reaction. So once we have an understanding about all these parameters which affects the, or all these factors which affects the rate of reaction, then as a chemical engineer, we can optimize these parameters in order to facilitate the reactions at a faster rate. Thank you very much for watching the video.